Hi everyone. In the last session, we covered a few basic questions on manual testing. In this session, we will go through some more important interview topics for manual testing. Let's begin the part 2 series. What is the difference between functional and non-functional testing? Let's understand the difference between functional and non-functional testing with the help of this table. Definition, functional testing checks whether the application works according to the given requirements, while non-functional testing focuses on aspects like performance, usability, and security. Purpose. The purpose of functional testing is to ensure the system does what it is supposed to do. On the other hand, non-functional testing ensures the system performs well under different conditions. What is tested? In functional testing, we validate the core functionality, inputs, outputs, features, and behavior. In non-functional testing, we validate factors like load handling, speed, compatibility, and reliability. Examples. Functional testing includes unit, integration, system, and acceptance testing. Non-functional testing includes performance, usability, security, and compatibility testing. When performed, functional testing is done early and continues throughout development. Non-functional testing is usually done after functional testing, often in the later phases. Tools used. Functional testing can be done manually or using automation tools like Selenium and QTP. Non-functional testing relies on specialized tools such as JMeter, LoadRunner, OWASP, ZAP, or Burp Suite. So, in short, functional testing asks, does the system work as expected? While non-functional testing asks, does the system work well under various conditions? Now, let's move on to the next question. What is the difference between black box testing and white box testing? Let's understand the difference between black box testing and white box testing. Definition. Black box testing focuses on testing the software from the user's perspective without knowing how the internal code works. In contrast, white box testing involves testing the internal structure and logic of the code. Other names, black box testing is also called behavioral testing, while white box testing is known as clear box testing, glass box testing, or structural testing. Focus. Black box testing validates whether the output is correct for the given input based purely on requirements. White box testing ensures that the internal code, logic, and processes are working as intended. Types. Black box testing includes techniques like functional, boundary value, equivalence partitioning, exploratory, usability, and regression testing. White box testing includes unit testing, integration testing, API testing, and security testing. Example, in black box testing, a tester may check whether the login feature accepts valid credentials and rejects invalid ones without knowing the backend code. In white box testing, the tester might verify whether the login function correctly queries the database and applies encryption to passwords. So, the key difference is black box testing asks, does the system behave correctly for the user? While white box testing asks, does the code and logic work correctly inside? Now, the next question. What are the different phases of the software development life cycle, SDLC? The Software Development Life Cycle, or SDLC, is a structured approach used in software engineering to plan, design, build, test, and maintain software. It ensures that the final product meets business needs, user requirements, and quality standards. The six main phases of SDLC are given in this image. Now let's discuss in detail regarding six phases of SDLC. Requirement analysis. In this phase, all requirements are gathered from stakeholders and users. It focuses on understanding business objectives, user needs, and technical constraints. Deliverable, requirement, specification document. Design. Once requirements are clear, the system design phase begins. This includes architectural design, database design, interface design, and system layout. Deliverable design, document, prototype, and system architecture. Development, coding. Here, developers write the actual code based on the design specifications. Programming languages, frameworks, and tools are used to build the system. Deliverable source code Testing. After development, the software is thoroughly tested to find and fix defects. Different levels of testing are performed, such as functional integration, system testing, and UAT, user acceptance testing. Deliverable test reports, bug lists, and test cases. Deployment. Once testing is successful, the software is released into the production environment for end users. Deliverable deployed application. Maintenance. After deployment, ongoing maintenance ensures the system runs smoothly. This includes bug fixing, performance improvements, new feature additions, and security updates. Deliverable updated versions or patches. In summary, SDLC provides a step-by-step framework that ensures software development is efficient, structured, and aligned with business goals. Now, here is the next question. What are the different phases of the software testing life cycle? The software testing life cycle, or STLC, is a structured process that defines the different stages of testing in software development. It provides a systematic approach to planning, executing, and evaluating testing activities with the goal of improving product quality and ensuring the software meets business requirements. And this is the block diagram of different phases in STLC cycle. Let's understand each phase along with its objective and key deliverables in a simple way. First one is requirement. Analysis. Objective. Analyze the requirements and identify what needs to be tested. Key deliverables. A list of testable requirements and any ambiguities that need clarification. Second one is test planning. Objective. Define the testing process, create a strategy, estimate resources, and prepare the schedule. Key deliverables, test plan, test schedule, and risk management plan. Third one is test case development. Objective, create detailed test cases, test scripts, and test data. Key deliverables, well-written test cases, test scripts, and test data. Fourth is test environment setup. Objective, prepare the environment where testing will actually take place. Key deliverables, a validated and configured test environment setup. Fifth is test execution. Objective, run the test cases, log the results, and record any defects found. Key deliverables, test execution, results and defect logs. And the last phase is test closure. Objective, evaluate the overall testing process, check if objectives are met, and formally close the testing cycle. Key deliverables, test summary report, lessons learned, and closure sign-off. In summary, the STLC ensures that testing is carried out in an organized, step-by-step manner, helping deliver a high-quality, reliable product. Now, move on to next question. What are the different levels of manual testing? Manual testing is performed at different levels to ensure that software works correctly from the smallest unit to the final product. Let's go through them step by step. Unit testing. This is the first level of testing. The objective is to verify individual units or components, such as functions or methods, to make sure they work correctly. Example, testing a function that adds two numbers. Integration testing. Once individual units are working, integration testing checks how these units work together. The focus here is on interactions between modules. Example, verifying that the login module interacts properly with the database. System testing. At this stage, the complete system is tested as a whole. The goal is to ensure the software meets requirements and functions properly in its entirety. Example, testing an entire e-commerce website, including browsing, checkout, and payment. Acceptance testing. This is the final level of testing. It ensures that the system meets business requirements and is ready for real-world use by the end users. Example, a client verifying a CRM system to check if it satisfies their business needs. Here, we explain the levels of manual testing in a structured way because understanding them in sequence helps in remembering and applying them during interviews or real projects. What is the difference between quality assurance and quality control? Let us now understand the difference between quality assurance and quality control in software testing. Quality assurance, or QA, is a process-oriented approach. It focuses on preventing defects by ensuring that the right processes, standards, and guidelines are followed during development. QA is proactive, meaning it works to improve the process before the product is built. For example, defining coding standards, reviewing design documents, or setting up proper processes are all part of QA. On the other hand, quality control, or QC, is a product oriented approach. It focuses on detecting defects in the actual product after it has been developed. QC is reactive because it comes into play once the product is ready, and the goal is to identify and fix defects. Examples of QC activities include executing test cases, finding bugs, and logging defects. So, to summarize, QA prevents defects by improving the process, while QC finds defects in the finished product. What are the advantages and disadvantages of manual testing? Now let's look at the advantages and disadvantages of manual testing. Starting with the advantages, manual testing allows real-time or live testing directly on the application. It requires very little or no programming skills, which makes it easier for beginners to get started. The initial cost is low since there is no need for expensive automation tools. Finally, manual testing is flexible and adaptable to changing requirements during a project. But manual testing also has some disadvantages. It can be time consuming, especially when the project is large or requires frequent regression testing. Manual testing also has limitations in coverage since repetitive or complex scenarios are harder to test thoroughly without automation. And lastly, there is always a possibility of human errors since the process relies heavily on manual effort. So, in summary, manual testing is simple, cost effective, and flexible, but not ideal for repetitive, large scale, or highly complex testing. These are some of the important questions we covered in this Part 2 series. In the next series, we will move on to more advanced level topics. Please comment below for any clarifications or queries. For mock interviews, online classes, or for any queries, you can contact us at the email ID provided. Don't forget to follow and subscribe for upcoming videos. Happy learning!